Hello, everyone, and welcome to our next presentation by Trish Cloud. She's going to talk about coding clubs and games. So without further ado, I'll turn over to Trish Cloud. But first, I want to go ahead and share the Techie Owls, because that's a really cool name. So go ahead, Trish.
Hi, I'm Trish. I'm from Grand Oak Elementary in Huntersville, North Carolina, and this is our website. It's techieowls.weebly.com. When this school opened a couple years ago, I knew our mascot was owls, and I teach technology, so that's where the name came from. And that's kind of what I've ended up calling all the kids at my school is the Techie Owls, because they're wise and they learn a lot of technology. And one of the things that I've done while I've been there has been to start a coding club. And that's the thing that I'm going to be talking to you about today is the coding club that I started for the elementary age kids. It's been really successful. We started out our first year with approximately 12 students. Last year I had about 25. I have a feeling I may have more this year because it's gotten around school about how much fun they have, because for most kids they equate coding with video games. So even though people may have their opinions on video games, for children that is their chief source of entertainment. I think most children would prefer to play a video game over just sit around and watch TV, because video games are not passive. You have to be engaged with your mind and with your body, with whatever part you're doing, whether you're doing something on a Wii or an Xbox Connect, or whether you are just using a controller or playing Minecraft. It's a very much of an immersive experience, and I think that's why children like them so much. So as I was getting ready for this, I was thinking about video games and coding and how it got here and why it's becoming as popular as it is. So for a presentation I did, I created an infographic. And do we have that up, or do I need to pull it up?
You probably want to go ahead and pull that up on your screen.
Okay, hold on one second. I'm going to take the camera off me for just a moment. And while I'm doing this, I have become a huge fan of infographics over the last year, because so oftentimes we see things and there's so much words, and we can't get the whole picture because we're too busy trying to read all the words. And so I really like these because of the fact that you can do them and get the idea of what's going on. All right, we're ready. Okay, just a second.
Actually, one quick thing. One of the things we're showing here is the live stream page. So for those of you watching and just getting oriented while we're getting this infographic up, is you will see the actual YouTube right here. You can see the Hangout. But also feel free to go ahead and post your comments over here in the side in Padlet. All you need to do is click on the little pencil here. So it's Add Post. And what we ask everyone to do is go ahead and type their name first, and then go ahead and write something about the presentation.
Okay, so this is the infographic I created about coding clubs in elementary school, because a lot of people don't understand why you would do this with elementary age children, but I say why not, because it's not something that's just for older people or grown-ups or high school kids, because these kids are seeing, and some of them are already doing coding even if they don't realize they're doing coding, because they play so much Minecraft, they're creating mods. Mods are coding. They're seeing how kids from all over the world on YouTube videos are doing things within Minecraft, and they want to know how to do it themselves. And so if I don't introduce it to them at school, they're never going to put the two together, and they're always going to see it as something that's not school. But it is school because it's a language that you learn, and it's very much based in mathematics. Somebody want to say something? I
Oh
heard
yeah,
somebody.
Trish. What I was going to say was in the last presentation with Leanne Teisling, what she discussed was that you have to look for the transferability when you're using these things.
Mm-hmm.
And you're right. That's what you're doing. You are with bringing it in there. You're showing them what they're learning there, and what they're learning when they're playing around on their own time and looking at mods. How it can be transferred into the coding that they're doing in school. So you're showing them that transferability.
Right. And for computer science, just with code.org and the Hour of Code, it is one of the hottest topics in education today. And some people think that you shouldn't be teaching it to young kids, but I don't agree. I think it's fun for them, and it's a popular way to keep them engaged in this and teaching them that it's not something dry and boring, because you hear a lot about computer science being, oh, it's so boring, you're having to learn all that other stuff. But for these kids, the way they're learning it, if I can embed in them at an early age that it's something that can be fun. There may be hard parts you have to learn, but it can be fun. I'm hoping that they'll continue it. And the basic logic of coding will serve them well as they move through school into college. This is some of the interesting facts that I looked up as I was preparing this, and that is computer science and computer engineering are two of the top paying college degrees that are out there right now. But of degrees in computer science and engineering, they only make up about 10% of the people who graduate from college. And here's a breakdown of majors that I got. Business is 30%, social sciences and history 15%, health professionals, education, psychology, visual arts, engineering, biology, computer and information sciences. And I have a link to the article there. Over 2 million students took the AP courses in 2014, and these statistics are from the College Board, who heads up AP. But only 1.68% of the high school AP classes were computer science. Here's a breakdown of this. Here you have your largest one, which here's biology, calculus, but when you get to computer science, it's all the way over there. And of the 2 million students, less than 32,000 took computer science. And of that, only 20% are girls. So here are the students taking calculus, and then females in calculus. Here is computer science, and here are the girls in computer science. So why introduce computer science in elementary school? It shows students computer science can be fun, and it keeps their interest. Whether you're using something like Codable, whether you're using Code Combat, whether you're using Hackatzoo, whether you're using an iPad or a computer, I found this year with a lot of my kids who had been with me for a couple of years, and I had taken them into Codecademy, they wanted to spend their time in Codecademy learning HTML. I had one boy who completely finished HTML and JavaScript, and so he was really interested in sitting there to see what he could create on his own just by coding it in himself in a code bit that Codecademy has. And as a 10-year-old boy, it involved bodily noises and pictures of dogs, but it was still pretty funny that he was doing that. Giving them this background base knowledge in elementary school, it will prepare them for a more rigorous computer science curriculum in middle school or high school. They're already going to have a base knowledge that is not going to have to be retaught them in 7th, 8th grade or 9th grade. They're already going to have, well, I know how to do that. I know what a CSS is. I know what HTML is. So it's going to open up to where they can advance even further with their high school or middle school. It brings familiarity. They know when they look. And one of the coolest things is I have a parent who helps me, and he came in and he brought up the source page from Google, and he had the kids look at it after they had been working in HTML for quite a while, and he asked them to look at that source code and see if they recognized anything. And the students were able to recognize the code right off the bat, and they went in and started changing the colors, they changed the font, and their faces when they realized they could actually change the way the Google page looked was amazing. You know, it didn't stay that way, but they could see the power of the code they were learning in that they could even change the color of the Google page.
Well, actually,
Go ahead, I'm sorry.
sorry. No, actually, one of the things that's really interesting is by them learning HTML, it's definitely going to help them later on. I basically am an administrator and teach in an online program, and I will tell you, knowledge of HTML will help you make your posts and make your work look exactly the way you want it when you submit it into any sort of learning management system. So it's one of those key things that key skill sets that I wish that a lot of our students are definitely learning either later in life, or if they can learn it earlier, it's better.
Exactly, and speaking for myself, we're learning a new learning management system in my school district this year, and in the editor, there's a place that you can go ahead and code in your own HTML, and that's true. You can make it the way you want it to look as opposed to the basic ways that they've got for entering it. So if you want to make your stuff look more lively, it helps to know HTML. It also sparks an interest at an early age, particularly among girls. One of the things that I'm looking into for doing this year to involve boys and girls is getting involved with maker stuff using Arduinos, LilyPad Arduinos, e-textiles, because I've got more girls progressively over the years, but if I can draw some more girls, that would be even better. And I have a feeling the actual making of something using fabric or making a stuffed animal that makes a noise, but programming the LilyPad to do what you want it to do ahead of time, it will take the coding to a new level for the students to where they actually can see it having real-life application outside a computer, if that makes sense, because just the maker side of coding as far as creating switches and lights and seeing things light up and making something that will make a noise when you walk by it. If they can see that, it will broaden their horizon beyond just video games, but see there are applications for engineering or going into some other field where they can make things with code. And it inspires them. It just does, because these are 6, 7-year-olds to 10-year-olds, but it gets them dreaming big at a young age. And their parents really like that they're dreaming in this way, because they want them dreaming beyond just the everyday, oh, I'm going to be the next David Beckham, to I'm going to be the next Bill Gates or Steve Jobs, because they're learning these skills at an early age to move on. So I do this by using fun web-based and mobile coding programs and let them experiment, have fun, and grow. This is not class. This is not, I am not killing and drilling. I am not saying you have to do this or you have to do that. I try to find things that are fun. It's an after-school club. I give them time to play and experiment, and if they want to sit there and make things spin around and around and around and around and around in Hopscotch, that is completely fine. It's their code. It's their project. So you get to try new things. You're playing with hardware and software, and I'm always looking for new things for them to try, because I'm kind of a person who believes that at this age, the more they know, it may be that one thing hits one child really well and that's what they like to zero in on, but it may be another program that clicks with another child. So I try to keep my options open at all times. And these are some of the programs that I'm using. Codable, which works really well with kindergartners, first graders, second graders. I even have fourth and fifth and third graders who still want to go back and use it because it's just cute, and it's gives them a way of just working on that logic of solving puzzles. Code.org has a wonderful curriculum for 2 levels of coding with the sections that you can enroll the students in, where they work through at a self-paced time of solving coding puzzles using Blockly and learning to code things, doing it that way. Plus, anytime during the year, you can go back to their hour of code and work through their puzzles. One of the most popular ones was creating a Flappy Bird game. I had so many kids creating Flappy Bird games, and they would change the way they looked or they changed the way they operated, but they had so much fun creating Flappy Bird games and then seeing how many people could beat their game. I've had a lot of fun with Lightbot this year. Its puzzles are somehow a little bit more complicated than Codables, but older kids really enjoy getting into that and discovering, getting that little robot to get all those lights on. Codecademy is a favorite for kids who are more advanced and are ready to jump into just working in the language. Hopscotch is an iPad, iOS-based program that is a lot like Scratch, where you use blocks to code. Hackett Zoo is one of my favorites, and it's an all-time favorite with the kids. It's like Rock'em Sock'em Robots, and you're moving robots to where they're trying to take out the other's core. And you do this, it starts out you doing it directionally, and as you progress in the game, you change from using directional arrows to actually typing in the JavaScript to move the robot along, and you have to be efficient in what you're doing because you have only so many action points. So it's not like you can just wander around until you get to the spot you want to be. You have to time it correctly. Gamestar Mechanic is not exactly coding, but what it does do is it teaches them the basics of constructing video games. And you learn mechanics that are called sprites. And what happens here is the students are able to see a connection between the code and the sprite. They can kind of see how a piece of code they learned from another place would work in this situation. And so they start making connections between game mechanics and the code that makes those mechanics happen. And then Scratch. Everyone is familiar with Scratch in that it's a great place to build games, tell stories, make movies, using Blockly code. It can be a little intimidating at first because there's so much, but I've found with my students this year, when I used it during class, they enjoyed learning to figure out the way things work. And we did use some of Google's coding curriculum a little bit at the end of the year this year, and that's tied in directly with Scratch. And so I had more students this year who were getting used to using Scratch and learning how to use that Blockly code. So that's pretty
We do have some
much.
questions.
Oh, okay, cool.
So, first question we have is, how long has the club been around? There's multiple questions here. So, how
Okay.
long has the club been around? Can anyone join the club? Is there a criteria for joining the club? So basically, how do people join the club? And then also, how many students are in the club and the age range?
Okay. The club has been around. This will be our third year. The school opened. This will be the third year the school opened. I started the club the first year we had the school. When we first started, I had 12, 13 students that ranged in age from first grade to fifth grade. Last year, I think I got up to about 25 students, and it was first grade to fifth grade. And so I don't have a, it's just who signs up. I have them sign up via a Google form. The only criteria that I really have is if they're in first grade, they have to have some fairly decent reading skills, because a lot of the coding that you do involves reading. I do have, in fact, I have a couple of high school juniors coming in this year to work with me to help the children do the tougher passages. But in the past, it's also been the fifth graders or fourth graders or third graders going over and helping the younger students, because they've already done it, they can read it, and they help them walk through the figuring out part. I will have to say that Code.org's curriculum is very easily accessible, and the students don't have to do a whole lot of reading with that. And what was the other question?
How many students do you have in age range? And then I think that's pretty much it for that question. So.
Okay. I imagine it's going to be close to 30 students this year, and it does range from first grade to fifth grade.
All right. And we have another question saying, is there a cost associated with the club? How is it being funded?
Everything I use is free right now. I personally did buy the one-time memberships to Gamestar Mechanic. They cost $2 a piece. But we did not use Gamestar Mechanic very much this past year. We might be running into some costs this year when we get into using the LilyPad Arduinos, but that's going to be completely optional on the parents' part if they wish to invest in a LilyPad pack for their kids. I do have one that was donated to me very nicely by a friend in my World of Warcraft guild, and and so I'm going to be showing them, demonstrating with that one. But I have a feeling, and I'm fortunate, I don't know if that's the word, but parents at my school are generally really willing to invest in things like this. So, but I generally do everything that's free.
Cool. So another question is, are you using some robots in your coding club? If you are, which robots are you working with, and how do students do with them?
We have used Dash and Dot. One of our students won them by writing a really cute little submission on Digital Learning Day, and we don't use them in the club very much. She took them home and she used them for a Genius Hour project in her third grade classroom, and so she showed them that way. We just never got time to bring Dash and Dot into the coding club, but that could be something we'll do this year. But Dash and Dot involve coding with Blockly, and it's fun in that way, but I think in a lot of ways kids would have more fun building the robot and then programming it. And that's something that this little girl's dad has done before. He is in the computer science field, and one of the first things he ever did was build a robot using something like an Arduino many years ago. So that's one of the Arduino projects we've been talking about, is getting the kids to the point to where we could bring them in and say, okay, let's build something with an Arduino and work towards building a robot.
Cool. We have another question. You're very popular. So what mobile device coding tools do you use, such as creating code for mobile devices, is the clarification.
There is a program, one of the projects within code.org is building a mobile app. I know that there's Codea out on the iPads, but I think it's like $10. So I've never really done anything on an iPad with coding on an iPad, because if there are free programs out there now to do coding on an iPad, I haven't explored them, because pretty much what we've been doing is just been on the computers, because the kids spend the majority of the coding club on the desktop computers. However, I do know that I've had a lot of kids do the building an app code.org project that's in there, because they really like that, because they were making a game that way. So yes, they've done it that way.
Cool. And I think our last question is you sort of addressed it there at the end, was saying how are you scaffolding the language, or how are you setting up a progression for your little kids to go ahead and as they age through the program, do you have a specific set of languages you're targeting? Like you start them off at like Codable and block coding, and then you gradually move them into like HTML and then or JavaScript, or is there any particular order you're going through right now, or is it just more of based on the resources you have available to you?
Well, Code.org's curriculum, their first section in their curriculum is beautiful for kids who have and I mean, even if it's, I usually start my first and second graders with that section 1 of their curriculum, because it's very basic, has minimal reading, and it's easy for them to grasp. If they're in 3rd through 5th and they've never been in the coding club, I start them at code.org section 2. It's a little bit more complex. By the time the young kids have finished section 1, I move them into section 2, because I really feel like they do need those 2 sections of just building the basics of moving the blocks and understanding how to make things move and drawing lines and repetition and competing and making repeats and loops and things. After they finish section 2 and they're in 3rd or 4th grade, I give them the option. Do you want to continue in block coding? If they do, I let them go to Scratch, because Scratch is very freeform. You can go into any of the projects on Scratch and see how they built it, and if you want to build something like that, you can get ideas on how they built their code. Or they also have projects in Scratch that can get quite advanced. So if they want to stay with block coding, I let them stay with block coding. But if they feel like they want to go ahead and move on into actually learning the languages, I take them in Codecademy and get them started in HTML, because personally I feel HTML is the easiest for them to grasp. Especially 3rd and 4th graders, because when you get into JavaScript, it's a lot more of a logic-based, and it gets a bit more complicated. And it's not that I'm saying they're not smart enough, but I just think developmentally, HTML is easier for them to grasp, because it's so straightforward. It's very factual. This does this, and it's not in any way nebulous in grasping the concepts of it. So that's why I start them in HTML and get them through HTML, and if they want to move on to JavaScript, then, and I have some kids going into 4th grade this year that pretty much have wrapped up HTML, and so I imagine they're going to be going for JavaScript or something else this year.
That's very cool. So we have another question. Is the coding leaking over, in quotes? to the regular school curriculum, or is it just limited to the club so far, from what you've seen?
As far as in my class, yes, it is leaking over because there's so much of what they're doing. We do a lot of coding in my regular technology classroom just because, to me, it is such a skill. It's such a beneficial skill, and it's something that at this point I can say, oh, we're going to do Lightbot today, and I don't get groans. I get, oh, yay, we're going to do Lightbot, because they don't equate it with schoolwork.
Mm-hmm.
They still think of it as something fun. And by doing this, a lot of kids do build websites in the class, either for a project they're working on or something, and by doing that, I can show them when they go in to build the website how to use HTML code to make it do or make it look the way they want to. So yes, there is a leaking over that way.
All right, I think we've answered the majority of questions that are out there. So the Q&A session will wrap up. But what I find really intriguing about all this is that we have so many, you have all these primary schoolers at your school as well as other schools in the nation that are learning the coding and computer science, being introduced to computer science early. What's interesting to me is seeing how secondary and post-secondary are going to address these students once they roll in, because it'll be really, really interesting to see if we can up our game as much as you guys have upped your game. So,
well, it's interesting to note that I ran into a middle schooler this past year, and I do know that the middle school, one of the middle schools that our students feed into, now has a game design club where they're having to design and code their games. So I do know that the middle school technology teachers seem to be ramping it up a bit, but none of the children that have been with me are anywhere near high school yet. So I don't know if it's made it to that level. I do know that there is regular computer science at my daughter's high school. In fact, the two boys that are coming to help me this year are two of my daughter's friends, and they're into computer science. So it's going to be interesting to talk to them and see what their perspective on computer science is when they get in and see what my kids are doing. So that's going to be an interesting follow-up point.
Very cool. Well, thank you, Trish, for redoing your presentation with us, and thanks everyone for watching. Everyone will have a presentation on the hackathon coming in about a half hour, so we'll see you again. Bye.